Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving length of longest Fibonacci subsequence. So the problem states that we are given an array that will be strictly increasing, and then we want to return the length of the longest Fibonacci-like subsequence of the input array that we are given. And if there is not a Fibonacci-like subsequence, then we just return 0. So if we look at these examples, the output of example 1 would be 5, because if we just remove 4, 6, and 7, then the array would be like 1, 2, 3, 5, 8. And if you look at it this way, 1 plus 2 will equal to 3, 2 plus 3 will equal to 5, and 3 plus 5 will equal to 8. So the length of the longest Fibonacci-like subsequence will be 5. And if we look at example 2, it would be 3. We can be formed with 1 plus 11 equal 12, or 3 plus 11 equal to 14, or 7 plus 11 is equal to 18. So the length of the longest subsequence would be 3. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use some dynamic programming. So what we will do is we will iterate from index 2 to the end of the array. And since the array is strictly increasing, then at each index we can use 2 pointers to keep track of all the combination of pairing that can add up to a certain number from the left of the index. So for example, 1 and 2 can add to 3, 2 and 3 can add to 5 when we're at this index, and 5 and 3 can add to 8 when we're at this index. So we can do that to keep track. So whenever we find a pair that can equal the index we are on, so let's take this for example, number 3, 1 and 2 can add up. Then what we will do is we will look at this grid that we have. We will look at row left and column right. So row 0, column 1. And then we will add 1 to whatever the number is at that place in the grid. So for this example, we will add 1 to 0. And we will add that number at row right and column index. So for this example, it would be row 1 and column index 2. We will add 1 to 0. That's how we will keep track. And then in the end, for the result, we will return the largest number on this 2D grid. And we need to add it by 2 because the first 2 numbers is not included in the 2D grid. So now that we have seen some examples, let's get to how we can solve this problem. First, we will be at index 2. The left is index 0, right is index 1. 1 and 2 add to 3. So as we have done earlier, we will add 1 to 0. Now that we have looked at every pair on the left and right, we will iterate to the next index. So the left will always start at 0 at every iteration. And the right would be 1 minus the current index we're on. So the right would be 2 and the index would be 3. And the result and the max result that we have so far is 1. So let's keep track of that. Now, if the pair equals the number that we are on, then we will move both the right index and the left index. If it is less than the number that we are on, then we will just move the left pointer over to the right by 1. And if it is less than the number we are on, then we will move the right pointer to the left by 1. And then we will continue until both pointers meet. So when the left is at index 0 and the right is at index 2, 1 and 3 does add to 4 at index 3. So we will look at row 0 and column 2, and then we will add 1 to 0 at row 2 and column 3. Now since it was equal, we move both pointers over, and so now that they have met, we will move to the next index. Now at index 4, 1 plus 4 is equal to 5. So then we will look at row 0 and column 3. It's 0, and then we will add 1 at row 3 and column 4. Since the pair equal to 4, we will shift both the left and right pointer, and we see that 2 plus 3 does equal to 5. So we will look at row 1 and column 2. The number is 1, so we will add 1 to 1, which is equal to 2, and we will add it at row 2 and column 4. And we also need to update the result since 2 is now our maximum number. Now since they are equal, we move both pointers again. So now that they cross path, we will now move on to index 5. So now that I think we have seen enough iterations, I will just let the rest of the problem play on its own. So yeah, 3 ended up being our largest number, but we need to add 2 to it for the first 2 numbers in the subsequence. So the result would be 5. So time complexity would be O of n squared, because we have to first iterate through each index, and at each index we will have to do a 2-pointer approach, so that will take n squared time. And the space complexity will also be O of n squared because of this grid that we have to make. So now let's get to the coding part. So first we will set up our double array for that grid. So 0 times length of array for I in range length of array, the result would be initialized to 0. Now for I in range index 2 to the length of array, we will first set the left pointer at 0 and the right pointer at I minus 1, while left is equal to right, so this is us doing the 2-pointer approach. The pair would be the left plus the right, and if the pair is greater than the index we are on, then we will move the right pointer to the left by 1. If it is less than, then we will move the left pointer to the right by 1. Else, if it is equal, then we need to update our dynamic programming grid. So right at index is equal to the left, row left, and column right plus 1. And then we update our result if necessary, so it will be the max of the new grid element or the result we previously had. And then now we need to shift both the left pointer and the right pointer by 1. So plus 1 and minus 1. And finally, we need to return the result plus 2 if we have a result. If not, then we just return 0. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave down in the comment section. And I hope to see you all again soon.